Hello everybody. In this video we're going to be Hello everybody. In this video we're going to write out the Lewis dot structure for ClNO. We're going to start by writing down which types of atoms we have. We have a chlorine, we have a nitrogen, and we have an oxygen. Next we need to write out their electron configurations. We can see that we have chlorine here, 3s2, 3p5, with a neon core. So this one is going to be neon, 3s2, 3p5. Nitrogen is going to be 2s2, 2p3 with the helium core. And oxygen, I'll spare you guys looking at the table again. It is 2s2, 2p4. It's the one right next to nitrogen. We need to add 2 and 5 together to give us 7 valence electrons. For chlorine, nitrogen is going to have 5 valence electrons. That's 2 plus 3. And we're going to get 6 valence electrons. For oxygen, 2 plus 4. Now we need to figure out our total, total number of valence electrons. We're going to have 5 electrons plus 6 electrons plus 7 electrons for a total of 18 electrons. Now we need to draw our skeletal structure. We need to decide which of these guys is going to be in the center. We want to pick the least electronegative atom out of these. And that is actually going to wind up being nitrogen. If that wasn't clear just from their positions on the periodic table, remember you can always look up the electronegativity of each element. We saw that in a table in chapter 6. So I'm going to place nitrogen in the center. I'm going to attach it to an oxygen, and I'm going to attach that to a chlorine. Now I formed 2 bonds, so I had, draw a little line here to keep this from being confusing, 18 electrons minus 2 bonds worth of electrons gives us 14 electrons left over. I can place those first on the terminal atoms. This guy already has 1, 2. This guy has 1, 2. So they can each take 6 electrons, 3 lone pairs apiece, before they get to their octet. So we'll start by doing that. One, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I had 14 electrons in the bank. I just burned through 12 of those, 6 and 6. I'm going to have 2 electrons left over, and those are going to have to be placed onto nitrogen. Now, we need to look at the octets here. So chlorine has 1, 2, 3, 4, 5, 6, 7, 8. He's got a full octet. He's happy. Oxygen 1, 2, 3, 4, 5, 6, 7, 8. He's got his full octet. He's happy. Nitrogen 1, 2, 3, 4, 5, 6. He needs somebody to share electrons with him. And the question really becomes, are those electrons going to come from oxygen and we're going to form a double bond between oxygen and nitrogen, or are they going to come from chlorine and we're going to form a double bond between chlorine and nitrogen? And that's not a super duper easy thing to answer. And in order to do so, we're going to have to consider something that is going to actually be brought up in the next section called formal charge. So what is formal charge? Formal charge is the idea, as you've seen in the book, we've railed over and over and over again, these are covalent compounds. They're covalent compounds. They share electrons. They are not ionic compounds. There are no ions here. Blah, blah, blah. And you know what? That's true. There are no ions here. Okay? But the idea of formal charge is basically, well, what if there were? What if they were ionic? Okay? And it's a little bit of a weird idea, but we're going to see how we can use this to make the decision as to which one of these guys is going to form this double bond. So let's write them both out, both options, and see how we can use this idea of formal charge to make this decision. Okay, so one of these guys is going to be our correct structure and the other one is not. In order to do this, we first need to figure out the formal charge on each one of them. And what this is going to involve is first writing down the number of valence electrons for each one of the atoms. So if we come back up here just to remember, chlorine's a 7, nitrogen's a 5, oxygen is a 6. So I'm going to write 7 here, 7 here, 5 here, 5 here, 6 here, and 6 here. Now, what we're going to do is we're going to subtract a number from each one of these. And we're going to get that number by doing a new count that looks very similar to the octet count that we did, but has one key difference. Okay? In our octet count, each dot counted as 1, each slash counted as 2. In this count, each one of the bonding pairs here is only going to count for 1. So a slash is 1 and a dot is 1. So let's do it from chlorine's perspective. 1, 2, 3, 4, 5, 6, minus 6. That gives it 1 plus, a positive 1. Nitrogen, 1, 2, 3, 4, 5, minus 5, he gets 0. Oxygen, 1, 2, 3, 4, 5, 6, 7, minus 7, he gets a 1 minus. Let's see how it plays out over here. 1, 2, 3, 4, 5, 6, 7. That's 0. 1, 2, 3, 4, 5, minus 5. That's going to be a 0. 1, 2, 3, 4, 5, 6, minus 6. That's going to be a 0. Now, the overall idea is that when we introduce formal charge like we have over here, that causes instability in the molecule. That is not the preferred configuration. We want the configuration where we have no or the minimal amount of formal charge on all of the atoms. This guy produces 0 formal charge on all of the atoms, so this is going to be our preferred configuration.